All right, it says here we are live. Welcome back. If you're subscribed, welcome. If you're new, so this should be short. This is a mental exercise in how to think about the problem of climate change and the Earth dynamic system. And we're going to get a little meta. We're going to talk about how things are reported, how things are interpreted. Science is a collective social exercise. We do this. We're looking over our shoulders at what the other scientists are doing. We're looking over the shoulders of other scientists to see what they are doing. People are watching us. We are watching them. Now, that may somewhat unwind the idea of empirical rigor or strict adherence to principles of truth or whatever that really means. Scientists as individuals can make mistakes. They can underemphasize things that they're not sure are important, but that's a subjective call. They can also overemphasize things that they are personally interested in and float those to the surface. So that's why peer review is important. And that's also why in our current dilemma, we actually need to work a little bit outside of the scientific process. It is our best tool for understanding complex systems. It's our best tool for floating to the surface things that are probably true, and for submerging things that are probably false or let's leave it at false for now. So where am I going with this? I'm trying to prime you for the idea that science is not a path, is not a unbroken straight path to the truth. A lot of the times we decide that something is true actually after the fact. Now you may say, well, that's kind of the same thing. No, it's not, because it means at the time you're doing science, you're kind of groping around, you're making mistakes, you're misinterpreting things, you're floating things up that are maybe not that important in the long term, but we won't know that until the long term happens. Okay, and that's fine. That's fine. The peer review process can take 20, 30 years to determine that something was a good idea or something was a bad idea. So my wife, who follows climate change topics actually a little closer than I do, she gets all the feeds and she's super curious about it, and she looks at it and she kind of provides me a filtering service. Really, it's like I'm a professor and she's a reader. Okay, so she's reading papers and she comes to me and says, "This is kind of strange looking. What do you make of this?" So that happened this morning. And what she brought to me, this presentation might profit from some graphs, but I'm lazy. I don't like editing, and I just do this extempore. Okay, so we're going to do this using narrative. We're going to do this using narrative, and you just follow the narrative and trust me that I'm not going to lead you astray. You shouldn't. You shouldn't. But this is my video, so if you're going to stay here, you kind of have to make that assumption for now. So my wife comes to me. She says, "Look at this chart." They've determined that this September has been the hottest September in 70 years. It was a chart of 70 Septembers, not 70 years, 70 Septembers in 70 years. So each temperature line was a September temperature. Now, if you were doing annual temperatures, you would probably take some sort of a mean of 12 months, but that's not what this chart was doing. It was looking at Septembers. And so you would expect the temperature anomalies or the temperature trends for any particular September to really be the same as any particular month. because they're all on the same trend. Yeah, Decembers are colder than Septembers in the Northern Hemisphere, but Decembers are also getting warmer, right? That's why it's called global heating. It's not just, summer global heating. It's called global heating, which implies four-season heating, and that's the case. In fact, just a quick aside. Um, in the same way that the poles, the Arctic and the Antarctic, are heating at a greater rate than the equator, it's called Arctic amplification, and we really should call it Antarctic amplification or just polar amplification. The rate at which the poles are heating is higher than the rates of heating at the equator. There's very sound reasons for that. And of course, this is an observation. This isn't a theory or a model or anything else. Has been observed. Probably people were a little bit stunned to find this to be true. And then they had to kind of scramble around and find mechanisms to explain why it might be more. In the same way that there's Arctic amplification, where the rate of warming at the poles is greater than that at the equator, there's also nighttime amplification. The temperatures at night are actually warming faster than temperatures during the day. And there's also winter amplification. So winter temperatures are deviating in a warmer direction to a greater degree than even summer temperatures. These discussions happen all the time in this area of work, and they're not even worth mentioning much, except that I'm just trying to make a point that to say that September is looked at in particular, it tends to be the hottest month in the summer, so it's a good proxy for like a misery index, right? The people were more miserable in September because of record heat, whereas averaging across all the months, it doesn't quite capture that same feel, right? Plus, of course, it's averaging out all the variations where winter is warming more than summer. So that's interesting all by itself. So annual averages for global temperature, while useful mathematically or useful for reporting data, or actually hide something that's very important. So getting back to the September data. So someone made a chart of all the Septembers for the last 70 years. It looks a lot like all the years for the last 70 years. There's a period of time when the temperatures aren't really going, they're varying, but they're not going up in a secular way. And then there's a period of time where they just kind of start shooting up, like out of nowhere. And our understanding of the mechanism for that observation is the CO2 in the atmosphere has reached a critical point where it begins to warm the atmosphere more than the planet can cool itself. So we're looking at the September data today, and researchers are saying things like that they're gobsmacked by how hot September was relative to previous Septembers. It's kind of a joke in our house. Yeah, sure, this September set records until next year's September, and that will also set a record. But I looked at the chart. She was saying, well, this September is hotter than any other September. Yeah, well, that's our life now. Everybody alive today is that's going to be the joke, is every September will be hotter than the one before, just as every year will be hotter than the one before. And every year will break the record that was set by the year before, and so on and so forth. Well, we're looking at this September, the one just behind us. And while there's a trend of warming for Septembers, the particular September was way up here, way off the chart. If you wanted to draw a line through all this kind of noisy data, you would draw a line like this, and then you would see this. Not on the line, not even close to the line. Very difficult to know if that's statistically important because you need a lot of data, and it's just one September. But probably it was statistically significant as a deviation. So I was looking at that, and I said, my first thought, as soon as I saw the chart, I said, that is not global heating, and that is not El Nino. So again, a quick aside. People are saying, "Oh, wow, this year, the oceans are already at record high temperatures, and then we're going into an El Nino phase of the ENSO, and so that's going to bump things up again by a little bit more. So we should really expect, the hottest year on record for 2023." And it's just, it's going to be significantly so because of the El Nino. The El Nino did this and the El Nino did that. And it's going to be an aberration. It's the El Nino. When I looked at that chart, I made a case. I said, listen, this September just passed. That data point, that dot, is neither on the line of global warming, and it's not on the line of El Nino, and it's not on the line of the two combined. And so what I pointed out is that the line that's going up and the little deviation around that line includes lots of El Ninos. And it's also to September data, but it doesn't matter. El Nino is a year-long or multi-year phenomenon. So there are Septembers when there was an El Nino, and there are recent Septembers when there were strong El Ninos, and we're not even in a strong El Nino right now. Our September was not conducted, if that's the right word for it. Our September data collection was not conducted during a strong El Nino. We have just entered an El Nino phase, and it's warm enough to be a concern, but it's not a record. And yet this September was way off the charts. And people are saying that they're gobsmacked. Now, I've been around a lot of scientists. I have written papers with peers, and we have, struggled to find the word that gives the right impression of the importance of an observation. And anytime you're in these discussions and we're trying to say, well, what do we want to call this? Do we want to call this extreme? Do we want to call this significant? And we shy away from it's alarming or it's gobsmacking. Okay. And even if it is, I can tell you, even if it is alarming, even if it is completely off the charts, even if they had to redraw the chart with different axes to fit it on the chart, because it literally went off the chart and they had to redraw it to make the chart bigger. Okay. Even if it is literally off the charts, they won't say, and this data is off the charts. They won't say it. Now, this comes under the category of scientific reticence. Scientists are reticent to say things like that. They think that it undermines their credibility, and much more importantly, they think it undermines their ability to get published, to get grants, to have collaborators, to keep tenure. I mean, there's enough reticence built into the system that if something is alarming, they won't say it's alarming. They might say it's significant. It represents a significant departure from the trend. It is a 4 sigma or a 5 sigma departure from the average, blah, 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 blah. And then someone comes along and says, this blew my mind. I am completely gobsmacked. I can't make heads or tails out of this. It's worse than off the charts. It doesn't make any sense. The data I'm looking at makes no sense. Where did this data come from? Is there an error here? Who collected this? I want to see the analysis. I want to see the meta. I want to see how they got to this point. Where did this piece of number come out of? What machine did this piece of number come out of? Because I want to see it. That's what they're more likely to say. They're just going to be in bald disbelief. And the September data for temperature for the planet, it has people in bald disbelief. Don't know what to think of it. Now, this follows on an episode that happened a little bit earlier in the year. Now we're in Antarctica, the South Pole, sea ice extent around the continent. The sea, their summer is our winter, and vice versa. Their minimum sea ice, which means basically their melt season, their summer, their minimum sea ice followed a trajectory that completely abandoned the plot of all previous years. So if all previous years are kind of going around a certain average and there's sort of a sine wave of maximum ice extent and then a minimum ice extent, then it goes back to the next maximum. And each year kind of follows the same thing. And some years are a little below the average waveform and some are a little bit above. And maybe there's a trend towards less in general. But the pattern in Antarctica has been so uniform that denialists have even been saying, look, at Antarctica, how can you possibly say, my phone is probably my wife. Hello.
Hi. Did you see that text I sent you about those beds? You must have seen them on Sheeley, right?
I'm right in the middle of recording a video.
Oh, okay, sorry, Steve. Bye.
She finds things. I try to take her call because she's out walking and who knows, something might happen. So denialists have even been saying that the uniform behavior of the ice extent in Antarctica disproves climate change, because if climate change is global as claimed, then the behavior of the ice melt should be the same in Antarctica as it is in the Arctic. So the global part of global climate change is not, you can't apply it. It's not true because it's not happening everywhere on the globe. Now, maybe there's a phenomenon in the Arctic, and maybe it has something to do with the atmosphere. Maybe it has something to do with something else. We don't know. This is how the denialists talk, because they look at Antarctica and it's behaving differently than the Arctic in terms of sea ice loss and maximum extent and minimum extent of the ice. Okay, fair enough. Fair enough. I will quickly remind everyone that the Arctic, the North, is an ocean, and it has different freeze and thaw dynamics on water than the Antarctic, which is entirely on land. When you look at the South Pole and you see a big white blob, that's largely land. The Antarctic is a continent. There are ice shelves, and they melt and then they refreeze back. And there's this, we have the concept of a maximum ice extent and a minimum ice extent, but a lot of the ice in question is actually on the land, and it has a completely different dynamic than ice looks the same from space on the water. And the water dynamic dominates in the north and is minimized in the south. So if you want to be a denialist and you want to look at the Antarctica and nothing is happening down there and blah, 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 well, that disproves global climate change. And however, this year during their melt phase of their ice cycle, the plot of ice loss in Antarctica was completely unhinged. It wasn't right. It was just it might have well have been the price of peaches, okay, because it just didn't match the data. It just didn't match the data. It wasn't like it was going in the wrong direction when it should be going down. It was going up. It wasn't that bad. But the line, the plot, the data for this year's melt season in Antarctica, I should say last year's, because they're going into a new one now. This is it's our autumn right here where I'm sitting, and it's their spring. So they're going into a new melt phase already. We'll see what happens. Last year's melt phase was just unhinged. It made no practical sense. It's almost like, who generated this data? Is this wrong? Did a satellite fall out of the sky or something? Did we lose some telemetry? What is wrong with this? And people were, again, gobsmacked. And if they wanted to climb out of their spreadsheets for a minute and scratching their heads, did I divide with the wrong number? Did I add when I should have subtracted? I got a math problem here. When they came out of their spreadsheets and their databases and started looking at the actual plot and what it would expect to do, they said, this is nuts. And they started using superlatives. This is gobsmacking. This is unhinged. This is off the charts. We're going to have to redraw the charts. This is crazy. So that little episode happened a few months ago. And I looked at that and I've been kind of waiting for some explanation. And they were thinking, well, maybe there's unexpected changes in the thermohaline circulation. Maybe there is something going on with the ozone hole down there. Don't know, hard to say. And you almost, we're at a point. See, this is Earth system dynamics, people. Okay, we're not analyzing your backyard pond. All right, this is Earth system dynamics. This is a big clock. This thing has a lot of gears. It is very slow to change. And when you see big swings in a machine this big, the appropriate expression is alarm. It's alarm. You should be alarmed. If you're not alarmed, then you're just not paying attention. You're not paying attention or you're in denial. And there are all kinds of denial. There's a kind of denial that I call soft denial, which is where someone who should understand the data, should understand the meaning of the trends, should be able to follow the analysis, should be able to follow the reasoning and the modeling and everything else, just doesn't address the gorilla in the room. When something like that happens, they'll say things like, well, we need more data, we need more study, more funding, we'll see what happens. We can only really understand the significance of something in hindsight. And I call that soft denial because it's all true. It's all correct. That is exactly what you're supposed to say. But you can also say, this is alarming. You can say that. Now, that's not going to get you a grant. That's not going to get you a grant. If you apply for a grant from the National Science Foundation or something, and you say alarming trends in the Antarctica, they're just going to circular file your application. Why would they do that? Why is there soft denial at all? There is something about human nature. There's something about human nature and our relationship with the planet that we just don't believe any of this. We just don't believe it. Even the people who study it just don't believe it. They just can't believe it's happening. They're looking at the data, they're studying the data, they're looking at the models, they're reasoning a way through, and there's a lot of work being done, and we're describing as many different parts of this huge machine as we can, as rapidly as we can, to try and understand what's happening, because we know on an intellectual level that something is happening. Something's happening. But on another level, on a personal level, okay, someone has a family and a career, and they got a mortgage to pay, and their commute is now 40 minutes instead of 10 minutes because of whatever's going on in the world, and prices are going up. On that level, they can't allow themselves to believe it. They just can't. They know it's true, but they can't process it. This is human nature. When you are confronted with things that just don't make any sense, most of us just turn away. We just turn away. I'm telling you that. I'm telling you that people just turn away. My favorite example, I'll use it on almost every video, is the sinking of the HMS Titanic. People just didn't believe it. And away came because it was supposed to be unsinkable. It says right here on the ticket, unsinkable. Okay. I'm traveling on an unsinkable ship. What part of unsinkable isn't registering with you? Don't tell me it's sinking. It says right here it's unsinkable. Okay. That is a problem. That is a problem. And people who have studied the Earth system, and there's not many, by the way, I'm a systemicist. There's not many systemicists. There's not many systemic biologists. There's not many systemic geologists. Everyone has their narrow field, whatever, something that was interesting, something they got turned on to in college, something that they thought would be profitable, as some advisor told them you should go into this type of zoology instead of that type, because this zoology gets better grants and has better publication history, and there's more graduate students, and this type of zoology is sort of old and funky, or it's wishy-washy, it's hippy-dippy stuff. So let's go over here and you do this and you don't do this over here. There's a lot of that goes on, okay? People get narrowly defined in because it works. Because taking on a narrow subject matter works. There are not many systemicists because it's hard, and it's hard to do hard science, good, solid, numerically driven science. Now, I've done systematic biology. It's difficult. I had to write software. I had to actually hack hardware. There wasn't enough computer power available to do the shit I wanted to do. It's one of the reasons I became a computer engineer, because I was very good at working with computers, because I was very dedicated to systemics. I'm still very good at systemic analysis. We have two metadata points. One of them is that the melt season during the Antarctic melt was unhinged. It didn't fit on the chart. It could have been the price of peaches or gasoline. Where'd this data come from? It's not expected. It's not expected. Now, it's not expected for people who study ice melt and the physics of ice melt and ice floats and the hot water and then the ice melts and it gets thin and it breaks up. Okay, for those people, that event was utterly unanticipated. Systemicists look for that. They don't expect to find it, but they're looking for that. The September number for the global temperature in September was just unhinged. And when I looked at it, I thought, oh, that is neither global heating nor El Nino, nor the two combined. That's something else. It's something else. Now, I say that because I'm a systemicist. I understand that these are systems that have complex behavior. And it's complex to the point that it's probably, except maybe with 100 years of work, incomprehensible to humans. It's so complicated. It's complicated, and we don't know how it works, and we are messing with it the way a toddler would mess with a grandfather clock. Okay, we're pulling gears out, throwing them away. This can't be useful. This didn't even turn while I was looking at it, so that can't be important. So we're messing with a machine that's very complicated, that we did not build. We don't know how it was built. It was built over millions, possibly billions of years, through all the interactions between the cryosphere and the biosphere and the lithosphere and the hydrosphere and every other type of thing, sunspots and continental drift and the whole thing. This machine was constructed and set in motion over millions of years, hundreds of millions of years. And we are like toddlers, just kicking it, throwing gears away, messing with things, turning them in the wrong direction. And we're messing with a very complicated system. In fact, using a clock to describe as a metaphor for the Earth dynamic system is laughable. Unless your clock has a million gears articulating with 50 gears by itself, and they're all turning, and some of them only turn some of the time, and some of them turn at other times, and the ones that come in at random times, and some of them haven't turned for tens of thousands, if not millions of years, but they can start turning again tomorrow. That's the kind of machine we're dealing with. Millions of gears articulating with hundreds of gears apiece, sometimes engaged and sometimes not, and sometimes randomly. Our ability to comprehend this thing is the prospect is not good. So the Antarctic sea ice melt was weird. It was weird. It was alarming. And people who didn't say it was alarming, well, okay, that's their bias. They got kids, they got a spouse, they got a mortgage. They don't want to say alarming things because they won't get their grant. They won't get published. No one will want to work with them. Their university will give them dumb grad students to do their future work for them. So they don't say the alarming thing. It's a practical matter. I'm just not going there. Don't ask me to go there. I can't do it. I've got other concerns. Well, you shouldn't, but okay, fine. I understand. You're in soft denial. That's fine. Other people will come along and they're They're going to be gobsmacked. They're going to be alarmed. They're going to be whatever. I'm one of those people. I've got 30 subscribers and I do one video a year when it suits me, if then. And, we don't get platform. We don't get views. We don't get anything. And that's fine. That's human nature. Nobody wants to hear it. I get that. I don't feel bad about it. I'm just surrounded by humans doing human things, getting on with their day, right? Now, I don't know why the Antarctic melt was gobsmacking. It was just weird, like it was the price of peaches, plotted against ice loss. It shouldn't be there. Too strange. What happened? And I don't know exactly why. September was just completely off the chart. I can tell you, it's not on the chart. It might as well be the price of peaches. Something wrong with that data. It's not global heating. I mean, it is, but it isn't. Global heating is built into that number. It's inside that number. And it's not El Nino. El Nino is in that number somewhere, okay? That number has an amplitude, and part of that amplitude is due to global warming and due to the influence of the El Nino. But that is not what that number is. It's not either one of those things or both of those things together. There's a third thing in there somewhere. There's a third thing in there somewhere. I don't know what it is. I'm a systemicist, okay? I understand systems. I'm looking at this data and I'm thinking, okay, they saw that number and no one could say why. It's because they're too focused on this other thing and this other thing and this other thing. And I got a grant for this and you got a grant for that. There's a third thing that someone missed. Now, maybe next year they'll say, well, that was because of something. I'm really interested to hear what that is. I really hope they come up with that. I really would like to hear the answer to that. Because that would tend to ameliorate my fear, my existential dread, my terror. And let me tell you what that is. After what happened in the Antarctica, with no explanation, and after what's happening right now with September data, don't know what that is. I have a concern that this system, not the temperature, not the humidity, not the anything, the system has broken. That this whole thing, this whole complicated thing is now on the move. It has made a move. It has made a breaking move. Like when that football player suddenly finds open field and just goes. They got the ball and they're running and they've broken from the pack and they're just going. And you're saying, oh my God, this was so unexpected. We've been playing this game for 2 hours and there hasn't been any break. And look at this guy. He's got the ball. He's running. He's going. Where's he going? I don't know. Is he going to score? Is he going to fall down? We don't even know. He's just running down the field. He's running down the field. And that play becomes the famous play of that game. That play becomes the thing that people talk about for a week. You see that guy go? How did he break out of the pack? I don't know. He went down the field. He did the thing. And that's all they want to talk about. We are now seeing system changes that are so off the chart, so aberrant, so out of place, that they are going to become the things that people talk about for a long time. Now, there's a theory that I keep hearing it sometimes, that, well, our high temperatures this year, I mean, because there's global heating is in there somewhere, but this is El Nino thing. And as soon as the El Nino was done, we're back to normal, whatever that means. Don't let them kid you about that one. Okay, the ENSO is normal. It's the tick-tock tick of this Earth dynamic system. And that is normal, okay? So when we're back to normal, I don't think you get it, but okay, fine. Moving on. Well, then things will cool off. Oh, really? Oh, really? You think so? Well, let me be the first to tell you that doesn't have to be true. That doesn't have to be true at all. We might not be going back to normal. People talk about the new normal, meaning this is now your normal. When the earth dynamic system is on the move, when it is on an excursion and the player has the football and it's going downfield and no one knows what's going to happen, he's got a wide open field. When the earth dynamic system is moving like that, when there is nothing in front of it, when there is nothing to hold it back, everything else you thought you knew is left behind, and it's an open field and it's going, okay? It's going there. We don't know where. It's going someplace and it's taking us with it. When that's what's happening, then you can't say, oh, well, this is the new normal. And now back to sports. You can't say that. You can't say that. That is a bias. That is normalcy bias. And you're going to use the word normal to try and make people think, oh, this is the new normal. Well, okay, it's just a little bit different than the last normal, I guess, except it's not normal. It's not normal for the earth dynamic system to be tearing itself to pieces. It's not normal for this kind of data to be showing up in long-term trends. This is not normal. This should not be happening. This is impossible. Given our understanding of the system and how big people think it is and how hard it is to steer this thing and how hard it is to move it, it should be unsinkable. It says right here on the ticket, unsinkable. It's impossible. Don't tell me the Titanic is sinking. It says right here. Well, here we go, folks. We're going someplace. I don't know where, but I think as of this year, given what happened in the Antarctica and what's happening with the global heating averages, I think that we just tripped over something, and this system is in trouble. It's going somewhere. I don't know. Things may come down, and we may look back in 20 years and say, yeah, 2023, that's when it broke. Something broke. And we may not, in 20 years from now, we may not even know what it was. And part of the reason why we may not know what it was that broke is that the science of studying this Earth system may be completely shut down. We may never know. We may go forward just being dragged by our noses, kicking and screaming, dragged through broken glass and broken dreams into a future that none of us counted on. And no one's studying it at all. And why would that be the case? Well, if there's anything close to a collapse of civilization or a collapse of governance or a collapse of our values, then there won't be money or funding or time to study this system as it falls apart. It might even be the case that it becomes illegal to study the Earth dynamic system, climate change. Some demagogues could get into enough government positions that they simply say, yeah, you can't talk about this. You're scaring people. It's a hoax. You're making stuff up. You're a terrorist. You're a terrorist. You're talking about global climate change and global heating. That's terrorist. That's terror talk. You're terrorizing people. We got a handle on this. It's just weather. It'll go back to the way it was. Climate changes all the time. It's not a big deal. And you're a terrorist. You're a terrorist. You're doing it deliberately. Whatever. You're going to make money. You're going to get grants for terror. Whatever they want to make up. They're just going to say, you're a terrorist, so labeled, and shut up, or we got a gulag for you. Or a courtroom. Or something like that. Shut up about it. That could be what happens. And sometime in the next 5, 10, 20 years, no one looks at this anymore. They just don't look. They either can't or they don't. What happens if there's a space-based conflict where one spacefaring nation goes after another spacefaring nation's assets in space? Satellites, right? So they start blowing up each other's satellites and EMPing them to death or whatever. And all of a sudden we're blind and we can't see the South Pole anymore. And we can't see the ice extent. And we really don't have instrumentation that covers the entire Earth. We don't really know what the temperature is on the entire Earth on an hourly basis, or at least a daily basis. And what happens? What if that happens? What if there's no more funding? What if a bunch of right-wing, alt-right, demagogic know-nothings get into power and say, oh, we're not going to fund this hoax of yours. We're not going to fund it. And as your satellites burn up and re-enter the Earth's atmosphere and go defunct, we're not going to buy new ones. You'll have the old ones until they die in place, and they are deorbited, and then you won't have any eyes in the sky. Ha ha! So much for your climate science, so much for your hand wringing, so much for your alarmism. What are you going to be alarmed about now? The price of peaches? Yeah, this whole thing come crumbling down because it's too alarming. If it gets too alarming, they might make it stop, folks. They might make it stop. And people might actually be clamoring, make it stop, make it go away. I don't want to hear it. I can't do anything about it. I don't want to hear about what's happening in the Antarctica. I don't want to hear about what's happening in the Arctic. I don't want to hear about the global temperature. It's just weather. This is bad. This is causing economic disruptions. This is increasing taxes. This is causing, impositions of regulations. I don't want to hear it. I don't want it to be true. I don't want to hear it. I don't want to see it. I don't want to smell it. I don't want anyone talking about it, not in front of me and not behind me. I want it to stop. And if enough people, in particular the wealthy, get to enough of the right kind of people who are managing budgets, then they could make it stop. So you might, at some point, I mean, if the thing really is on the hot skids to hell, and suddenly somebody realizes that, you might stop hearing so much about Earth, global temperature, and sea ice extent in the Arctic and the Antarctic, and extinction of polar species, and disruption of ecosystems, and rising sea levels, and the status of the AMOC, and you might just stop hearing that. It might just go away because it's coming unglued. And maybe the best way to handle a problem like this, when things are coming unglued and we don't even know why, and we don't even understand the system well enough to even start to explain it, all we can do is just continue to fuck with it, because that's progress. That's the global economy is fucking with things. Then the best solution might be is simply make it go away. That's the place we're in. This data is so weird and so off the chart and so scary, so alarming. They might just make it stop. Now, as I often say, physics doesn't care. People who think the Earth is flat, Earth is still round. People think the moon is painted on the sky. Moon is still a satellite. People think we didn't go to the moon. We went to the moon. We left junk on the moon like we leave junk everywhere else. Reality, it still happened. Reality is still real, and physics doesn't care. So we'll see. I just wanted to say all that. It probably went on longer than I really needed to, but I'm alarmed at the data. I am deeply concerned that the Earth dynamic system has just slipped a gear. And I don't know that we ever go back from here. I don't know that we can ever go back. I don't know what's ahead of us, but I'm alarmed that we cannot go back now. Something broke. Something is breaking. It may not even be completely broken. What if there's more breaking in process? What if whatever it is broke continues to break and continues to fail us and betray us? And we don't even know what it is. All we know is that things are coming unglued. Things are coming unhinged. What is this? What's going on? We're scrambling around. I don't know. But at some point, we don't go back. This is a very grim moment right now. This is very alarming. If you wanted to be alarmed, now is the time. Be concerned. I'm telling you, the system has slipped a gear. I guess we'll know more later. Hopefully, I'm completely wrong, but I don't see how I could be. And this is going to happen a lot. This is going to be more common than we can probably even guess. And we don't have till 2050 to figure this out. We may not have till 2025. We may be unmade at this point.